So then we have something that looks like this. And so if I graph the parent function, we have x, y, and this one again, the parent function is the absolute value of x. And so if I plug in these values, I'm going to go -1, 0, 0, and 1, which means I get 1, 0, and 1. And we've seen this function enough today that I can plug in this, and with pretty good certainty, I know I'm going to get a graph that looks like this. And so there's my absolute value function. And so this graph should be moved. Well, we have to figure out which direction it's going to be moved. So I'm not, this time, the function itself, the +5, is outside of the absolute value. So I've got to do the absolute value first and then add 5, which is a little different than what we were doing before. So if I put -1, the absolute value of -1 is +1, and I add 5 to it, I get 6. If I say put 0 in, I will get 5. And when I put 1 in, I'll get 6 again. So if I plot those points at -1, I'm up here at 6. 1, 2, 3, 4, 5, 6. At 0, I'm at 5. And at 1, I'm at 6. So it looks like my absolute value function, because I know this is an absolute value function because it says that in the equation, is a V shape. Then I get the graph that looks like that. So you can see that when it's outside, it's up or down. So outside the function, outside the parent function, outside parent function, it's up or down movement. And this, I know it's up because it's positive. Positive is up, negative is down. So when it's outside, you follow the signs. I could have just taken this function, moved it up 5 units, and that would have been the same thing as this graph right here. So hopefully you're starting to see a few shortcuts on this. Now this one has 2 transformations. So we need to figure out what's going on with this. All right, so I'm going to graph the parent function, and my parent function in this case is x squared because of the square there. So don't be fooled by this, all this crazy writing. And so I'm going to pick the same values I picked before, -2, -1, 0, 1, and 2. And when I square them, I get 4, 1, 0, 1, and 4. Same things I've gotten before. So I'm going to plot my parent function. And so I get the graph that looks like this every time for this parent function. If I could hit some points here. Sorry, I missed points, but you get the idea. So then this function over here, I've got to follow my order of operations and simplify this. So I'm going to pick my same values, -1, 0, and 1, and see what happens. Well, if I put -1 in here, I get -2. -1 minus 1. I owe somebody $1, I subtract another $1. So I owe somebody $2, but I square it. Now I'm up to 4. So 4 minus 3 is 1. Plugging 0 in, I get +1 when I square it, and I subtract 3, it gives me -2. When I put 1 in, I get 0 for this thing, so I'm at -3. So let's plot these points and see what happens. If I'm at, so I have this point in common, and then I'm at 0, I'm at -2, and at 1, I'm at -3. So maybe this is the U-shape kind of curving down this way, but I'm not 100% sure. So let's keep going. Let's try 2 and see what happens. If I plug 2 in, 2 minus 1 is 1. 1 squared is 1. Minus 3 will give me -2. And so if I would have chosen -2, which is a possibility, -2 would have given me -3. -3 squared is 9. 9 minus 3 is 6, so you can see I'm going the other way that I didn't really want to go. 1, 2, 3, 4, 5, 6 would give me a point up there. So that's why I chose the direction I did, because I was looking for this U-shaped graph. So I bet if I choose 3 in this case, 3 minus 1 is 2, 2 squared is 4, 4 minus 3 is 1. I get this other point right here. And so you can see, here's my U-shaped graph. Now, let's look at what happens translation-wise according to this. Well, here is a number outside the function. Outside the function is the same direction. This says I go down 3 units. from the parent function. So down 3 units. Did I go down 3 units? 1, 2, 3. Yes, I did. There's the bottom of my graph. This one, we go the opposite direction. It looks like it should be -1, but it's right 1. Oops, right 1, which means I moved it this way. So if I go down 3 in right 1, there's my vertex, and then I end up with the exact same parabola that I had in the blue one. And so you should be able to look at these equations and figure out which way the graphs are moving. So here we are, we're at our out, and our out basically says write a function that has a vertical translation and a horizontal translation and graph it. Basically, you could use, if it's got both, I'll write you a couple, you can graph them. Here is an absolute value function, x plus 3 minus 2. That will move it, well, you probably figure this out, down 2 and left 3. Okay, if I write one that looks like this, y equals, and even if I did x squared plus 3, so if I did this, if I did x plus 3 minus 2, and this thing squared, it will be the same thing. Left 3, down 2. Okay, but this one would be a U-shaped graph, and this one would be a V-shaped graph, and so that's kind of what we're talking about. And so just understand how these functions are moving. So I hope you enjoyed our webinar today, and have a good day.